So now we come to Lewis dot structures for covalent compounds. Covalent means to share electrons. And after you watch the first video, you'll see that that if the electronegativity is greater than 1.7, you're ionic. If you are less than I can't spell than, less than, actually it should be than, not then, less than 1.7, then you are covalent and you are sharing. Now, there are a number of different rules for covalent bonding, and they are all summarized on Appendix F. And I will show you a picture of this. If you cannot find your appendices, let me know and I will email you a copy of it, because you'll want to have Appendix O and Appendix F handy when you do the homework, okay? So, and they're also found in your textbook, but Appendix F and Appendix O kind of summarize it nicely. All right, so let me just show you a picture of Appendix F, okay? So Appendix F summarizes the rules of where did my picture go? There we go. All right, so there's Appendix F, okay? And the rules for each group is above. So you can see there are the rules for group tap anywhere to add a drawing. Use 2 fingers anywhere. Okay, so I can't do that as I thought. So group 2A, group 1A, you can see on the left-hand side. Group 1A wants to have 2 electrons around it. Okay? So oh, geez. Okay, so I guess I can't write on this, sorry, but the group 1A wants 1 electron, or 1 bond and 2 electrons. Group 2A wants 2 electrons, wants 2 bonds and 4 electrons. Group 3A wants 3 bonds and 6 electrons. Group 4A wants 4 bonds and 8 electrons. The most important row is the second row that's listed there, the one that goes 2, 4, 6, 8. That row tells me that how many electrons I must have around my element when I am done. So everything in group 1A must have 2 electrons around it when I am done. Group 2A must have 4 electrons around it when I am done. Group 3A must have 6 electrons. Group 4A, 8. And then when I look at groups 5, 6, and 7, they all want 8 electrons. Okay? So 8 electrons is what they are looking for. Oh, here we go, finally. So group 1A wants 2 electrons, group 2A wants 4 electrons, 3A wants 6 electrons, group 4A wants 8 electrons. And then these 3 groups, they all want 8. Okay? If that makes any sense at all, that these 3 groups must have 8 electrons around it when they are done. Okay? All right, so let's go back to notability. And let's do, let's start off with one that's one of the most common molecules in the world, H2O. Okay? So oxygen goes in the center because there's fewer oxygens. Hydrogen goes here, hydrogen goes there on either side of it. Okay? Hydrogen is in group 1A, so it has 1 electron. You can put the electrons wherever you want now. In molecules, you can put the electrons anywhere. Oxygen is in group 6A, so it has 6 electrons. All right? Then I have to check the electronegativity. If I go to my electronegativity chart, you will see that oxygen has an electronegativity of 3.50, and you will see that hydrogen has an electronegativity of 2.20. So oxygen is 3.5, hydrogen is 2.2. So when I take the difference, I end up with 1.3, which is less than 1.7, so it's going to be sharing. Okay? So when it's sharing, I'm going to go back to Appendix F, and I'm going to look to see how many electrons does hydrogen, oxygen want. So hydrogen's group 1A, oxygen is group 6A. So when I go to my chart, it shows me that group 1A wants 2 electrons, and group 6A wants 8 electrons. So I got to get 2 around the hydrogen and 8 around the oxygen. So the way I'm going to do this is I'm going to move these 2 electrons down here, and my hydrogen is going to move 1 electron here, 1 electron here, and the hydrogens are going to put theirs here, and then I'm going to draw a circle around to show that there are now 8 around my oxygen, and there are 2 around my hydrogens. So this is how I get 2 around every hydrogen and 8 around the oxygen. It takes a lot of practice, and I highly recommend a pencil when you do these homework problems. Okay? Let's do another one. So let's say we've got aluminum chloride. Okay? So aluminum is the fewer of them. I put my chlorines around 3 sides. Okay? So aluminum is in group 3A. So it means it starts off with 3 electrons. Chlorine is in group 7A, so it starts off with 7. Okay. I go to my electronegativity table. Chlorine is 2.83. Aluminum is 1.47. I take that difference. So the difference between aluminum take the absolute value. I get 1.36. Okay, so covalent. So now I know I'm going to share electrons. Now how many do I have to get around the aluminum? How many do I have to get around the chlorine? So I go back to Appendix F. So chlorine is in group 7A, so it wants 8 electrons. Aluminum is in group 3A, so it wants 6 electrons. So I gotta get 6 and 8 are my numbers, okay? So the way I'm going to do this is I'm going to move one of my electrons over here. I'm going to move another electron over here, and then my third electron I'm going to move right there. So then I can see now that I've got 8 around that chlorine, 8 around that chlorine, 8 around that chlorine, and 6 around the aluminum. Okay? Now, this is called the Lewis dot structure. I can also draw what's called the line bond structure, where I just draw a single line to represent every shared pair. So this would be my line bond structure for aluminum chloride. Okay? Let's do a couple more examples. How about we do yeah, it's a little bit more advanced, but let's do nitrate, or let's do chlorate. All right. So now we've got a charge up in the upper corner. All right. So the chlorine goes in the center. I got 3 oxygens that go around it. Now, the electronegativity difference, chlorine is 2.83, oxygen is 3.50. So when I take the difference, I end up with 1.67. No, I end up with 0.67. So it's below the threshold for ionic. So I'm going to be sharing. Now, chlorine is in group 7A, so it's got 1, 2, 3, 4, 5, 6, 7 electrons. Oxygen is in group 6A, so it's got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now, the negative charge means that I get 1 extra electron that I can put anywhere. Okay? So I'm going to represent that extra electron with a star. So I'm going to put a star right there, okay? The reason why I put it there is because I've done these a long time and I know kind of how this needs to work. Oxygen must have 8 electrons when it's done, and chlorine must have 8. How do I know that? Oxygen is in group 6A, it follows the rule of 8. Chlorine is in group 7A, it also follows the rule of 8. So the way I'm going to get 8 electrons is the chlorine is going to share both of its. Okay, you don't always have to take one from one and one from the other. So chlorine is going to share its 2 right here. And we're going to share these. So 8, 8, 8, and 8. Because there's a charge on this thing, we put brackets. We always put brackets when there's charge. And that's the Lewis dot structure for chlorate. Now this ties back into naming because when we went all the way back, why does chlorine want 3 oxygens? Because that's what it needs to get its 8 electrons. And why does it form a -1 charge? Because that's what it needs to get its 8 electrons. We're going to do sulfate, and we'll see that sulfate, why sulfate follows the rule of 4. Remember, we said sulfate was part of passes. Now we've gotten to the point where we can explain why this is. So I put my sulfur in the middle. It's group 6A, so it's got 1, 2, 3, 4, 5, 6. Put my oxygens around the outside. Oxygens are in group 6A as well. So 1, 2, oh, I can do better than that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So both the sulfur and the oxygen need 8 electrons around it. So by sharing, the oxygens are getting 8 electrons. But this oxygen down here is not getting 8 electrons. In addition, the sulfur needs 8. How do I know the sulfur needs 8? Well, if we go back to my little chart here, it says here that sulfur is in group 6A. If sulfur is in group 6A, it's going to need 8 electrons. So this is the reason why sulfate forms a -2, because I'm getting 2 bonus electrons. And I'm going to put those 2 extra electrons right here. So I've got 2 extra electrons that I got from somewhere. Probably I beat up a sodium to steal them. And I have a -2 charge. Now the sulfur has 8 and the oxygen has 8. Okay, and that's how we do covalence. Now, again, I show this all on video in my of me actually teaching it on my YouTube channel, Strauss Verona. I will make one more video on how to do some of the resonating structures.